Hey friends, I'm super excited because this week we're going to start working on adding and subtracting decimals. And before we get into a whole lot about how to add and subtract decimals, it's important to talk about estimating as a skill to use to check whether or not your answer is reasonable. When you estimate, you get a close enough answer. Then when you calculate the exact answer, you know that you should be pretty close to your estimate, or else it's kind of a clue that you've made a mistake. So that's why we estimate. Okay, so let's start with adding problem number one. Or no, it looks like problem number one is subtracting. So let's actually go out of order and start with number two. We're going to talk about not only how to add these amounts, or how to estimate adding these amounts, but also how to record your work for this. Sometimes kids have a hard time understanding how they should record their work for estimating because they think, isn't the point of estimating to do the work in your head? You should record expressions or equations that show the work that you did in your head, and it doesn't have to be a whole lot of extra work either. In the video on Envisions, they talked about rounding or using compatible numbers to estimate the sum to an addition problem. So let's take 7 and 4/10. We can round that to the nearest whole number, which is 7. And then when we take 3 and 1/10, we're going to round that to the nearest whole number, which is 3. And it just so happens that 7 and 3 are also compatible numbers that equal 10. 10 plus 9 and 8/10 is easy to add in your head. That would give you 19 and 8/10. Or if you wanted to continue rounding, you could round 9 and 8/10 to another 10, and then just simply add 10 plus 10, which would give you 20. Either of those would be perfectly acceptable ways to estimate. So when I look at your work, I'm going to expect to see expressions that show the rounding or compatible numbers that you found, and then finally an estimate. You do not need to calculate the exact number or the exact answer for these problems. Just an estimate is fine. Let's backtrack to number one, which is a subtraction problem. 5,602 minus 2,344. Now for this problem, we don't have any decimals. We're going to subtract it, and they're just whole numbers. Think about compatible numbers that you could use to subtract these two amounts easily. Now the nice thing about estimation is that there's a lot of different ways to estimate any one given problem. You could start by taking 5,602 and rounding it to the nearest 1,000, which is 6,000. Then look at 2,344. Round that to the nearest 1,000, which is 2,000. 6,000 minus 2,000 is 4,000, so that would be a perfectly acceptable estimate. Let's say you wanted your estimate to be a little closer to the exact answer. Let's round this first number to the nearest 1,000, which is 6,000. And then leave 2,300, round that one to the nearest 100 instead of to the nearest 1,000. 6,000 minus 2,000 is 4,000, as we've already discussed, minus another 300 is 3,700. So this would be a little bit closer to your exact answer than 4,000. Either are perfectly acceptable ways to estimate. Okay, now number 3 is another addition problem. So we're going to add 2,314 plus 671, and we need to think of either compatible numbers or we can round. Let's say you decided to round these numbers to the nearest 2,000, or to the nearest 1,000, sorry. 2,314 would round to 2,000, and 671 would round to 1,000. And of course, we can add 2,000 plus 1,000 easily. That would give us 3,000. If we wanted to be a little more exact, we could try to find some compatible numbers. So we can take 2,300 and then round 671 to the nearest hundred, which is 700. Now 300 plus 700 gives me 1,000, and 2,000 plus 1,000 gives me 3,000. So either way, I know that my answer should be somewhere in the ballpark of 3,000. Okay, let's move on to our subtraction problem. 54 and 23 hundredths minus 2 and 39 hundredths. We need to either round these numbers or come up with some compatible numbers to help us subtract them. If we want to round to the nearest whole number, 54 and 23 hundredths would just round to 54. 2 and 39 hundredths would round to 2. And it's pretty easy to subtract. 53 minus 2 is 51. So our answer should be somewhere in the ballpark of 51. Let's say you wanted your estimate to be a little bit closer to your exact answer. Maybe consider changing 54 and 23 hundredths to 54 and 5 tenths. Then subtract just subtract 2 and 4 tenths. So we're taking our 39 hundredths and changing it to 4 tenths. So 54 and 5 tenths minus 2 will be 52 and 5 tenths minus 4 tenths will be 52, and 1 tenth. So this is another way to think about your estimation. For this next problem, you're going to have to write the dreaded sentence. I know kids hate questions like this, but try to think of it this way. It's only 10 to 15 words out of your life. You can do that. Wesley estimated 5 and 82 hundredths minus 4 and 21 hundredths to be about 2, or approximately 2. Is this an overestimate or an underestimate? Meaning, will his exact answer be more or less than 2? So in order to decide if this is an overestimate or an underestimate, I think what we have to do is think about what Seth did, or what Wesley did to these numbers in order to get 2 as his estimate. I'm guessing that he probably took 5 and 82 hundredths and rounded it to the nearest whole, which is 6. Then he rounded 4 and 21 hundredths to 4, meaning he removed a portion of each number. He took a portion of each number off of the whole number. Or to say it in a better way, really what I should say is he increased the value of this number by about 2 tenths. So he increased the value of his first number, and he decreased the value of his second addend. Since he increased the value of his first addend and decreased the value of his second addend, we have to figure out if his estimate is more or less than what he would have gotten if he had calculated the exact answer. So when I thought about it that way, I decided that Wesley's answer was an overestimate. When you take 5 and 82 hundredths and subtract 4 and 21 hundredths, if you rewrite it like this, you can see that you don't have any borrowing or regrouping that you're going to have to do. And so your answer should be somewhere close to This should be your exact answer. So this is an overestimate. Write a sentence about that. This next question asks you to estimate the total precipitation in inches and the total number of days with precipitation for Asheville and Wichita. Now, if you don't know what precipitation is, this question might confuse you a bit. Precipitation is any kind of rain, snow, sleet, hail. It's basically your wet weather. So any day that it was snowing, raining, sleeting, or hailing is a day with precipitation. And you can see that in Asheville, North Carolina, they had an average yearly precipitation of 47 and 71 inches. So that's almost 48 inches, or 47 and 71 hundredths of an inch, I should say. And then for Wichita, Kansas, they had 28 and 61 hundredths of an inch. That was their average yearly precipitation. So you can see that, of course, Asheville, North Carolina gets a lot more precipitation each year than Wichita does. They're asking you to estimate the total precipitation, meaning combine these two places, and then the total number of days with precipitation for Asheville and Wichita. So you're doing inches of precipitation, estimate that total, and total number of days with precipitation. So you have two estimates that you need to make for this one. Use your imagination and imagine two boxes, one box that weighs 9 4/10 of a pound, and the other box that weighs 62 6/10 of a pound. Estimate the total weight of these two boxes, one of which weighs 9 4/10 of a pound, and the other one which weighs 62 6/10 of a pound, using rounding and compatible numbers. Which estimate is closer to the actual total weight and why? So you need to have two estimates. Estimate number 1 and estimate number 2. Then you need to come up with a judgment about which one you think is closest to the total weight of these boxes. Good luck and have fun.